if now we're again interested about the same location, okay, so this is also still our point A, right? Point A, right? And we still, shear flow is still the same. The area of interest now changes, okay? So now the area of interest is this area, okay? And then this is the what? This is now our thickness. You can see the difference now, right? You can see the difference, okay? However, there are also similarities, okay? So now, if I want to find at point B, right, the thickness is the same, right? The thickness is the same. And now the area of interest is also the same. Okay, so if it's at point B, I'm going to highlight this is the area that you have to consider. Okay, so for thin wall analysis, it's the same. Okay, it's the same. So thick or thin wall analysis, there are differences. There are also some similarities. Okay, so now let me stop by talking too much theory. Okay, let's look at an example first. Okay, so the example I'm going to look, or we're going to do, has a combination of thick wall and thin wall structure. Okay, so let's look at the example. So this is before I go any further, anyone, any questions? Anyone, please? Okay, I don't see any question being asked. Are you there? Can someone say yes, I'm here? Anyone?
Yes, sir.
Okay, you are there. I thought I'm doing the Thanksgiving weekend teaching where the names are there, but no one is there. Okay, now at least I know you are alive and kicking. Okay, right. So let's look at an example. Again, this example can be found on Avenue to Learn in under, I think it's under week 5 lecture. Okay, so let's look at the example. Okay, number 1. So I'm going to look at a. So example number 1. Okay, so again, you guys will have all these. Before I do example, let me see. Okay, before I do example number 1 in full detail, I want to do some examples on constructing shear flow. Okay, and it's very interesting. Okay, or let's call this example number 1. Okay, so this is example number 1. Okay, the thing about thin wall analysis, you have to construct the shear flow first. If you if you don't know how to construct the shear flow, you cannot do your analysis. Okay, so example number 1, right? So this is a bit confusing. Is it a box beam or is it a wide flange? Okay, then I'll throw another one in. Okay, now some of you like, oh no, right? I'll throw another one in. Okay, I'll throw another one in. As you all know by now, I love to make your life confusing, or I love to pick difficult problems for you. Okay, as you can see in your term test. Okay, as I said, a lot of you did well for your term test. I'm so happy, you know. Okay, let's look at this. Okay, right. Two very confusing feature. Okay, so before I make up this rule, I was also confused like crazy. Okay, so we're gonna apply rule number 5, right? the web controls the flow, right? So if you look over here, right, on the feature on the left, there are how many web? So this is a web. These are webs. These are web, and these are web, right? The one on the right, also the same thing, right? This is a web. 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 So rule number 5, Eugene state that, hey, the web controls the flow. Which web? Okay. So the web that controls are the one that's continuous, i.e., from the top of the structure to the bottom of the structure is continuous. So for this case, right, the construction of the shear flow on the left-hand side is controlled by here. Because the web is continuous, yes or no? Okay. Now, on the right, it's the center one because it's continuous, yes or no? Right? So the web controls the flow. Then after that, you start designing the rest of the structure. Okay, so I'm going to the left first. So the left, okay, so fluid have all the, fluid has to flow this way. Right? And then it will come in this direction. And then when it's reached here, fluid has to be coming from here. Right? And then fluid has to be going in this direction. Okay? Then on the one on the right, same thing, okay? So on the flange, top flange, the fluid will come this way. Will come to the center. Right? And the fluid will have to stop somewhere. Okay? And then the other side is the same. Hey, no, the other direction. Hey. So now over here, okay, we realize that this structure on the left, where I draw 2 dots, this is our terminal. And then where everything starts or ends, these are our terminal. Okay. So this is one example of the one on the left. It looks like a box, but in fact, you need some white flange analysis. The one on the right, it looks like a box, but it's white flange. Okay, so you need to analyze this. Okay, but before you gain more experience analysis, I like to do one example. Okay, which hopefully will help you understand the analysis better. Okay. Anyone, any question up to now on rule number 5? Okay, I don't hear anything, and I don't see anything on the chat. All right, so let's do example. Again, this example can be found on your what do you call it, on Avenue to Learn. Okay. Okay. So knowing that a given shear flow V cause a maximum shearing stress of 10 KSI. So we know that shear max is equal to 10 times 10 to the power 3 PSI. Okay. In a head-shaped extrusion show, so they call this a head-shaped extrusion, determine the corresponding shear stress at point A and point B. So we have to find the shear stress at point A and point B. Okay. But we only know that tau max is 10 times 10 to the power 3 PSI. Okay. So the first thing we have to do, okay, I'll copy this image. Okay. First thing we're going to do, we're going to construct our shear flow. Okay. So we know that over here, this is our shear force in the vertical direction. Then next we're going to construct our shear flow. So over here, the shear flow, one will go towards the left, one will go towards the right. Then it will come down. Or let's apply what I've taught you. Okay. So if we look at rule number 5, before we go to rule number 5, let's quickly recall. Okay. So rule number 1, V and I are constant.
Sorry, we can't hear anything.
Muted. Someone muted me. You can hear me now, okay? Yeah, tell me earlier if you can't hear me, just voice out. I can't hear you, sir, okay? Or I can't hear you, Eugene, okay? So the shear flow is controlled by the shear flow direction. Is controlled by the web. Okay. So over here, right? The rules still apply. Okay. The 5 rules still apply. V and I are constant. Data as centroid and starts from the Y max. First moment of area cannot cross the centroid. Number 5, the shear flow direction is controlled by the web. Okay. Still okay. So we consult. So we know that the shear flow is controlled